Hello, welcome to the SciCon Machine Learning Tool tutorial. Today we're going to be covering K-nearest neighbors regression. K-nearest neighbors regression is a non-parametric way of predicting continuous values. It does not make assumptions about the underlying distribution of the dataset. The predicted output is the average value of some number k nearest neighbors. The advantages of this method are that it is a simple method with no training step and requires few parameters, usually only requiring you to input the k and a distance measuring method. The challenges of this method are that it is slower with larger data sets and does not work well with data that has many independent variables. The steps of k-nearest neighbors regression are as follows. Number 1, set a number of nearest neighbors, or k. Typically, this is defaulted to 5. Number 2, calculate the distances from the new test data point to all other data points in the set. Number 3, determine the k closest data points. And number 4, calculate the average of some number k closest data points. The output of this is the model's prediction. There are multiple ways to measure distances in k-nearest neighbors. Here are two common ones. The Euclidean distance, which is the straight line distance between 2 points, represented by the blue arrow and the leftmost equation, and the Manhattan distance, the distance between points when moving only along horizontal and vertical lines, represented by the red arrow and the rightmost equation. This is a visual of how k-nearest neighbors regression works. A new data point is inputted, the k-nearest neighbors are selected, and their averages are calculated to provide an output. This model can be evaluated multiple ways, one of which is the coefficient of determination, or R-squared value, which is the proportion of the variation in the dependent variable that is predictable from the independent variable. An R-squared value closer to 1 means that there is a small difference between predicted and actual values, so the model is a good fit for the data. The mean squared error, or MSE, is the average squared difference between the predicted values and the actual values. A small MSE value means that the predictions are close to the actual values and the model has high accuracy. So our experimental data set relates to phytomining, so this is just a quick introduction to phytomining. It is the process where special plant species are cultivated with the goal of harvesting them to obtain metals from soil. Our data focuses on the plant tissue dry weight and the internal rare earth element concentrations within that dry plant tissue. These are the first few rows of our data set. As you can see, the dry mass is shown in grams, as well as the micrograms per gram concentration of each rare earth element, and finally, the total rare earth element concentration in micrograms per gram within the dry tissue. This is the SciCon machine learning artificial intelligence tool. We're going to start by naming our project and adding a description. Next, we're going to select our data type. I'm going to select tabular because I'm working with a CSV file. Next, I've already clicked on this icon and uploaded my plant mass element data.csv file. And it shows your data right here. You can also click on this data tab and it provides information on your data, such as the number of rows and columns. Next, we're going to select a target label. In this case, I'm going to select total rare earth element concentration. Next, I'm going to select a machine learning algorithm method. Then I am going to pick the k-nearest neighbors class. Once I have my k-nearest neighbors regressor picked out, I'm going to pick a category to evaluate the model. In this case, I'm going to select my R-squared value, and then I'm going to click Perform. So as you can see, the R-squared value is 0.99, which is very close to 1, so the model is a good fit for this data. We can also check the y-test, and y-prediction values. The y-test values are the actual values that are retrieved from the data set itself, and the y-predictions are the outputs that the model has estimated. This has been the SciCon machine learning tool tutorial for K-nearest neighbors regression. Thank you for watching.